Let's now try and do the second reaction of a base. This time I'm going to use a metal hydroxide reacting with an acid. Again, it's going to produce a salt and a water molecule. So let's do this reaction. I'm going to take magnesium hydroxide. Mg is in group 2, so it has a charge of 2 plus. Hydroxide is OH and it has a charge of 1 minus. Using the crisscross method, the formula is going to be MgOH2. And I'm going to remove this 2 plus and this 1 minus, so it's MgOH2. That's magnesium hydroxide. I'm reacting it with phosphoric acid, which is H3PO4, and it's a base plus acid reaction, so a salt would be produced and a water molecule would be produced. I just need to figure out what the salt is going to be. So I'm now going to neutralize this acid, get rid of the H, and substitute this H with the other positive ion, which is magnesium ions in this case. Substitute magnesium in the position of hydrogen ions. So replace the H plus 1 with magnesium. If I do that, I'm going to get magnesium phosphate. It's going to be Mg and PO4, except the fact that PO4 has a charge of 3 minus, Mg has a charge of 2 plus. So the formula is going to be Mg3, and there would be 2 PO4s. And I should remove the charges. The overall charge would be 0. They would add up and cancel each other out. So this is the formula of the salt that would be produced. The next step is I need to balance the equation, and again you balance the elements that are coming in the least number of places. So let's start with magnesium. It's only occurring in 2 places. So there are 3 magnesiums on the right hand side. There should be 3 molecules of MgOH2. That would give you 3 magnesiums on the left hand side. Then the easiest to balance is phosphorus. There are 2 phosphorus over here. There's only 1 over here, so I need to balance that. If I have 2 molecules of H3PO4, that would be balanced. The next element that I would try and balance is hydrogen is coming in 1, 2, and 3 places, whereas oxygen is coming in 1, 2, 3, and 4 places. So I should balance hydrogen first. There are 2 hydrogens over here, but there are 3 molecules, so that would mean that a total of 6 hydrogens over here, and there are a total of 6 hydrogens over here. So that's a total of 12 hydrogens in the reactant side. So there should be 12 hydrogens in the products as well. So there should be 6 H2O water molecules. And lastly, you're left with oxygen. Oxygen should automatically be balanced. It was the most difficult one to balance. There are 6 oxygens over here. There are 8 oxygens over here. So that's a total of 14 oxygens. There are 2 phosphate ions in this molecule. So that's a total of 8 oxygens. Then 6 oxygens over here. So that's a total of 14 oxygens. So oxygens are balanced as well. So the reaction of magnesium hydroxide with phosphoric acid produces magnesium phosphate and a water molecule. Let's do another example of, and this time we have sodium hydroxide reacting with phosphoric acid. So it's another metal hydroxide, another base reacting with phosphoric acid. So the formula of sodium hydroxide is Na is 1 plus, whereas OH is 1 minus. So the charges would cancel each other out. So let's remove the charges. So the formula of sodium hydroxide is going to be NaOH, and it's reacting with phosphoric acid, which is H3PO4, and this would end up producing, it's a base plus acid reaction, so a salt would be produced and a water molecule would be produced. So let's figure out what the salt is going to be. Remember, again, the salt is produced when an acid is neutralized. Get rid of the H in the acid and substitute that H plus 1 ions with any other positive ion, so the acid would be neutralized. This time the positive ion is sodium ions, so it's going to be NaPO4. So I'm going to write Na and PO4. Na is 1 plus, PO4 has a charge of 3 minus, so the formula using the crisscross method would be Na3PO4. So it's going to be Na3PO4. That would be the salt that would be produced. Get rid of the positive and negative charges. The overall charge is going to be 0, and I need to balance this equation now. So to balance this equation, look for the easiest element to balance first. Na is 3, so there should be 3 sodium atoms on the other side. There should be 3 molecules of NaOH. Then you have phosphorus, which is already balanced. The next element that is easiest to balance is hydrogen, because it's only coming in 3 places. So there are 3 hydrogens over here, there are 3 hydrogens over here. That's a total of 6 hydrogens. So there should be 3 water molecules. That would give you 6 hydrogen. And the last element, which was the most difficult one to balance, is automatically balanced. There are 3 oxygens, 4 oxygens over here. So on the left hand side you have 7 oxygens, and on your product side you have 4 oxygens and 3 oxygens. That's also 7 oxygens. So the oxygens are also balanced. So a balanced complete equation of of NaOH reacting with H3PO4, giving you sodium phosphate and a water molecule. Let's do this third reaction now, in which iron 3 hydroxide. Iron is a transition metal, so the charge or the oxidation state of iron is always given in the formula. So this 3 over here means that iron has a charge of 3 plus. So iron 3 hydroxide is reacting with nitric acid. So I'm going to write down the formula of iron 3 hydroxide first. Iron is, the symbol is Fe. It has a charge of 3 plus. Hydroxide is OH, and it has a charge of 1 minus. So according to the crisscross method, the formula is going to be Fe, and there would be 3 hydroxide ions. Using the crisscross method, get rid of the charges, they get cancelled out. The overall charge is 0. So this is FeOH3, this is iron 3 hydroxide, and I'm going to react it with nitric acid, which is HNO3. So it's a base, metal hydroxide, plus an acid reaction. Base plus acid produces salt and water. So write down water first. Water would be produced, and we're going to figure out what the salt is going to be. Salt is produced when the acid is neutralized. Get rid of the H in the acid and replace it with the other positive ion, which is Fe3 plus in this case. So we're going to get rid of the H in the acid, remove the H. So it's going to be Fe and NO3. Now Fe has a charge, it's iron 3, so Fe has a charge of 3 plus, NO3 has a charge of 1 minus. So using the crisscross method, the formula is going to be Fe, NO3 would be thrice. And let's remove the charges now. The overall charge would be 0. So this is the formula of iron nitrate, which is the salt that would be produced in this reaction. And the last thing we need to do is we need to balance this equation. Fe is already balanced. There are 3 nitrogens over here, so there should be 3 nitrogens on the other side as well. So there would be 3 molecules of HNO3. And there are a total of 3 hydrogens over here, 3 hydrogens on this side, so that's a total of 6 hydrogens. So there should be 3 water molecules. And lastly, you need to balance the oxygens. Oxygen was the most difficult one to balance. It was appearing in 1, 2, 3, and 4 places, so that was the most difficult one to balance. There are 3 oxygens over here, and there are a total of 9 oxygens over here, so that's a total of 12 oxygens. There are 9 oxygens in 3 HNO3 molecules, and the 3 oxygens over here, so that's a total of 12 oxygens. So oxygen is also balanced. So this is a balanced equation of iron 3 hydroxide reacting with nitric acid and producing iron 3 nitrate and 3 water molecules.